In this video we have a trigonometric integral to evaluate. We got an integral of sine to the third power times cosine to the fifth power. Both odd powers here. So the key to this is picking the right substitution, and there could be more than one substitution, especially here since the powers are odd. One might be longer than the other. But here's what I'm going to do. You can pause the video here if you want and see if you can figure this out. I know the derivative of sine is cosine. Derivative of cosine is minus sine. So we can set it up so we can have that function here. So I'm going to do it this way. Let's say sine to the third. Then the cosine, I'm going to break this up into cosine to the fourth and cosine of x dx. And we're kind of grouping these together here. So I'm going to say let u equal to sine. And like I said, you could probably work it out also if you let u equal to cosine and separate one factor of sine over here. So instead of cosine x dx, you could have sine of x dx. Your answer might look different, but it's not going to be incorrect. So then here, du, derivative of sine is cosine. So this would be cosine of x dx. So the idea again is to transform this integral into an integral involving u instead of the x. So right here, du is cosine x dx. So cosine x dx, that's this one here, can be replaced by du. So let's just do this gradually here. This is the integral then. And here I have sine cube x, but sine of x is u, so this can be replaced by u to the third. And then cosine to the fourth x, that could be replaced by, let's do it this way. So I could put cosine squared here and then square it. Cosine squared of x in the parentheses and then square it. That gives me cosine to the fourth. But then cosine squared can be replaced by 1 minus sine squared. That's your main identity. Fundamental identity, cosine squared plus sine squared equal to 1. So from that, I can write cosine squared, which would go here in the parentheses, by 1 minus sine squared. But sine squared would be u squared, because u is sine of x, so this will be u squared. And then cosine x dx, that's replaced by du. From this right here. Now it's just a matter of multiplying this out. Got u to the third. 1 minus u squared squared. This will be 1 minus 2u squared plus u to the fourth. It's like squaring up. Well, we're squaring the binomial. So square the first one minus twice the product of the two terms plus the square of the second term. Get this. And this is du. And then we continue multiplying the expression there, u to the third times that polynomial. So this will give me u to the third. Multiply the next term by u to the third, me minus 2. U to the fifth plus u. U to the third times u to the fourth, that's u to the seventh. So this simplifies to just taking the integral of a typical polynomial in U. So we integrate term by term here using the power rule for integrals. So adding 1 to the 3 there gives me u to the 4th. And then we divide the coefficient by that. It's 1, so this would be 1/4, or I could just put it over 4 like this. Minus, add 1 to the 5 in the next one, I get a 6. Divide the minus 2 by 6, or reduce it, that becomes a 1/3. And then plus, add 1 to the 7, s u to the 8th. Divide the coefficient, 1, that'll be 1/8, or just put it over 8, like this. Plus your constant of integration. Then all you got to do now is go back to the original variable. Right now we have it in terms of u, but u is sine x, so all we have to do now is just replace the u by sine x. So this will equal to then sine to the 4th of x over 4 minus, and then to the 6th power for the u, so this will give me sine of x to the 6th power it's over 3. Then the next one has u to the 8th, so that'll be sine to the 8th, and that's over 8. And then you have your constant of integration. So we have sine to the 4th of x over 4 minus sine to the 6th power of x over 3 plus sine to the 8th power of x over 8 plus c. That's your answer. Thanks for watching. We'll see you next time.